Hi, this is Mr. Mitchell. I'm getting some feedback that balancing chemical equations is something that people are having a hard time with. And I know I've made another video on it, but let's have some more practice here. So in balancing chemical equations, there are a couple of things you have to know. First of all, you have an arrow that's in the middle of these chemical equations. What is on the left side of the arrow, I mean every atom that is represented on, and every element that's represented on the left side of the arrow has to be represented on the right side of the arrow also. So for example, we're going to see how many Fe's, which is iron, is on the left side and how many Fe's, which is on the right side. Another thing to know on balancing chemical equations that you have two different kinds of numbers that you see here. The larger numbers that come before the chemical compounds and before the chemical elements, those are called coefficients. And the numbers that are smaller, that are down at the bottom, are called subscripts. Now the rule is you cannot change a subscript. These numbers at the bottom, the 2, the 3, the 4, the 2 here. The only ones you can change are the coefficients. This number here, this number here, this number here. Those are the only things you can change. So what I've done here, I've kind of taken a different approach in that I've given you two equations here, one of which is balanced and one of which is not. So here's how you tell. Take every individual element and see how many there are on the left and the right. Fe is iron. There are two Fe's here because the coefficient 2 means that you have two of those Fe atoms. So we go over to the other side of the arrow, and though we don't have a coefficient 2, we do have a subscript 2. So yes, there are two Fe's on the left side and two Fe's on the right side. Is that true at the bottom? 2Fe, 2Fe, yes. So both of them are good as far as the iron atoms, Fe. Let's go to the next one. Oh, here's a difference. We have 3 in this equation. We have 2 for the coefficient. So to find out how many hydrogens are in this one, we have 3 times 2. That's how you treat a coefficient and a subscript. We already have two hydrogens before you add these subscripts here. So whenever you have a subscript and a coefficient, my bad, this is a coefficient, you would multiply them. 3 times 2 is 6. So yes, there are 6 hydrogens, H's, on this left side. Let's go to the other side and see what we have. Do we have 6 on this side? Yes, we do. We have 3 coefficient times 2 the subscript. Let's go down to the bottom. Here we have 2 times 2. That's 4 hydrogens on this side. Let's go over here. 2 times 2. Yes, that's 4 hydrogens on that side also. So the hydrogens are good on both equations. Now let's go to the SO4s. You may remember this is a polyatomic ion, and if you don't have to split it up, you don't have to. You don't have to find all the S's and then find all the O's if they are staying together. So how many SO4s are here? Well, there are 3 of them here because having this coefficient here means there are 3 of everything that happens to be in here. So there are 3 SO4s. Now I know you may be saying, why don't we multiply 3 and 4 together? If we were just finding the oxygen, you would do that. But if you're finding the SO4s, then it is just 3. Let's see what we have over here. How many SO4s? Well, it's 3 of them because we have this subscript here also. So this top one looks like the balanced equation of the two. Let's see where we went wrong on the bottom one. How many SO4s here? Looks like 2 of them. How many SO4s here? Yeah, there are 3 of them here. So this bottom one is not a balanced chemical equation. That equation would not happen in nature because you can't just add an SO4 that just magically appears. You have to have the same number on both sides. Okay, let's look at the bottom one and see which one is balanced. Now this would be a point in which you could pause the video and see if you can figure out which one is balanced. I'm going to keep going because you are able to pause the video and I will just keep on going along. Let's try these C's. One of these two is balanced, one is not. Let's have 3 times 2, that is 6 C's on this side. How many C's are on this side? Looks like we have 6 C's on this side also. How many H's on this side? 3 times 6 is 18. How many H's on this side? 6 times 2 is 12. So this one is not balanced. You have to have the same number of hydrogens, same number of H's on both sides. So let's make sure that the bottom one is correct. 2 times 2 is 4 for the C's, and there are 4 C's here. 2 times 6 is 12 for the H's. 6 times 2 is 12 for the H's. We have 7 times 2 on the oxygens. That would be 14 of them. Oh, and here we have an oxygen here and an oxygen here. So we have to add up to 14. How many oxygens here? Looks like we have 6 of them. And how many oxygens here? Looks like 4 times 2 is 8 of them. So 6 and 8 is 14. So yes, the bottom one is the one that is balanced. So that's the process you go through when seeing which equation is balanced. Now hopefully you can do well on these practice problems that I will have coming to you later. Thank you.